Hi everyone, welcome to my channel. In today's video I'm going to show you how artificial intelligence can make life easier for any ETL developer or data analyst. We see how you can use OpenAI GPT 4.0 model to help with source to target ETL mappings, one of the most time consuming part in any ETL processing. I'm going to demonstrate this in two ways here in today's video. One with using API, OpenAI Web API, and another is with running it to local LLM that is actually running on my own system. Both way it is going to result you same things. The only difference it like open AI Web API will give a faster result in compared to local LLM because local LLM needs a lot of compute to operate. So by the end of this video you will see how AI can quickly generate mapping sheets, suggest transformation logics and save the hours of manual work. So let's go and start. So if you see here it's a Streamlit web UI. So I have used it for the faster implementation. So right now this application is stopped and if you see it is running on my local host. And here what I have done actually I simply provided a prompt. There I'm not giving any instruction. I'm just giving a table definition to it. I'm uploading the file. That file can be a CSV file, that file can be a text file, it can be a XML file, it can be a PDF file. So based on the file, this file it will treat as a source and this it is a treat as a target. And once you hit the generate X mapping sheet, so there you can see two buttons I have created. One with you can go with OpenAI API and another you can go with a local LLM. So in either way, so this particular result whatever is seeing here it's actually generated by the local LLM. So if you see here it is giving a pretty much everything like what is your source, what is your source column, what is the transformation logic, what is your target, what is your target column, and at the end of this mapping that is it is showing in actually a grid. You can actually download it in the form of Excel also. So this is the final output of this particular implementation. Let's go to the VS Code. So actually I tried it multiple ways, frankly speaking. I try with here where actually I'm generating through the web API. I'm trying here with where actually I'm just using my local LLM and everything. So I thought like why can't we mix both of it for in a single video. Okay, so here is my code. So let me explain the code. These are the actually things I'm using here. One is Streamlit for the faster baby UI, pandas to read the CSV or any data related files. This is the stream.io and bytes.io. This is actually going to help us to read the text and basically convert them into Excel format. Request actually I'm using because I'm using the local LLM in this code, and OpenAI because I'm using the web API. Okay, in the next this is the PDF because I'm actually tried PDF also. I haven't used it, but if there is a PDF that also we are reading as a text file. This is just a page configuration. What is the title of the page and everything, what is the header of the page, everything like what is the design and what kind of markdown table we are going to use. All these things instruction we are giving it like for the tabular format and all. This is the sidebar. So sidebar, let me show you. Okay, so this is the sidebar. So sidebar is basically giving you two options. You can set the temperature, you can set the token. Temperature is basically once you set the temperature it will give you the most accurate result, and the token is basically nothing but a number of words you can say in the simple language, but it is not equivalent to number of words. One words can be 1.4 or 1.5 tokens actually. Okay, so this is the input it is taking from the sidebar. Okay, now it is going to that input prompt. So if this is the text area because where you actually provide your input prompts. Input prompt is nothing but you like what is your target tables and all. Here we have a file uploader. So what kind of file you are going to upload, that is actually going to be hold into the upload files variable. This is the file handling portion. File handling portion is nothing but like what kind of file you are going to upload. Based on that, it is reading the file data into this particular file name. And if it is a CSV, it is reading into data frame. If it is any other, it is reading as part of that text format, and that it is going to store into the file content. Okay. This is the base prompt. So base prompt is nothing but here I'm instructing my LLMs like what you are, what rules you have to follow, and what kind of result I'm expecting from you. So once the base prompt is covered, I'm adding it with the user prompt. That is what I'm getting from my source, and on top of that I'm adding the file that user is going to upload. So that file is nothing but your source file. So here no, it's not required your source file will always be with data. Your source file can be with simple DDL definition also. It work in both way. Because I'm running on this my local systems, I'm taking the first 2000 character of the file, but in the real time we can increase it. That is not a problem. Here these are the two simple functions. One function is basically parse markdown table to data frame. So whatever the markdown table is going to be created, that we are converting into data frame, and that data frame further we can convert into Excel. So these are the two functions that is going to help it. So I'm going to give this in my Git repository. Anyone can download from there this code. I'm just trying to explain the code here. So this is the OpenAI client. I'm here connecting with OpenAI client. So to connect to OpenAI client, you have to set the OpenAI key. So if you see here in the Streamlit folder, I have secret.toml file. So in the secret.toml file, basically I'm having a API that is actually I got from my OpenAI Playground account. So you can simply log into Playground account and you can take your API key from there and you can use here. So I think right now they are providing some $18 free credit to use it. But on top of that, if you want, you can add your credit card and you can use it pay as a go. Here I'm creating two different buttons. So one button is basically belongs to that OpenAI API. Another button is for local LLM. So this is the code that is actually calling the OpenAI API. So what I'm doing here, I'm simply checking like if the prompt is entered or not. If the prompt is entered, I'm calling the OpenAI API. I'm sending the model GPT-40 mini. Okay, one more thing here, like one can use GPT-5 mini also. So GPT-4 mini and 5 mini are best suitable for this work because they are very good in data analysis and text processing. So we are not actually processing any other thing other than that these two. So this is the 4 mini. I think they are charging 0.015 or $25 per 1 million tokens. So this is good enough for us. So here I'm using GPT-4 mini. If you want, you can use 5 mini also here. I'm here setting the temperature and maximum token here, that actually I got from the sidebar, if you remember this sidebar thing. Okay, and here I'm setting the rule. I'm telling it what exactly you are. You are a ETL mapping generator, and you are actually working for insurance industry. So that is what. And now I'm sending the base prompt. Base prompt is a combination of pre-prompt or base prompt plus your user prompt plus your file. Okay, so remember these things. So actually when I'm passing it as a full prompt. It's a big prompt. Okay, because I'm not using any agent right now, I'm directly using the open model. So I have to tell the model every time like what you have to do. Okay, so that is the limitation of this kind of implementations. Now whatever I'm getting is as a part of response. That response actually I'm storing into mapping text, In the mapping text, I am further converting into markdown table. Okay, so why I'm doing this? Mapping text is nothing but a very simple text output. The text output further I have to convert into a tabular format. So I will not get, I will not actually can show that any rubbish result, correct? Like I just need a tabular format data. That is what I want. I am giving you a specific type of requirement. I want a specific type of output. So that's why I'm forcing it to convert it to markdown table. And once the markdown table is converted, actually we can use the data frame, and that data frame further we can use to convert into the Excel file. Similar way we are using for local LLM also. So in local LLM, if you see here, I am requesting to my local host API, and here actually my model is GPT OSS 20 billion model. So this is my 16 GB RAM model actually with M4 chip. So this is the best compatible model actually that I can run here. Here also I am passing the base prompt. Once the base prompt is resulting the result, that result what I'm doing actually, that I'm doing the internal iteration of each line of the result, and I'm converting into a text format, and further I'm actually splitting into a kind of a tabular format. That tabular format further actually I'm converting into my data frame, and that data frame I'm converting into the Excel. Okay, so this is the code. Okay, and this is the output. Now let's run it. So how you can run it? You have to say Streamlit run, then your path of that particular file. Let's run. Let's close this old one. So now you say what you want. So I'm having different prompt here. So let me actually fine tune to the directly what I want for that. So let me copy this one. If you see here, I'm not giving any good prompt. I'm just saying generate ETL mapping for these target table, and I simply passing the target table name and columns, nothing else, and it should work for it. Control V. Now I have to upload a source file. So this is my source XML. I'm uploading it. Now I can generate result with OpenAI API, or I can generate with local LLM. So let me run OpenAI LLM, OpenAI Web API first, because it will give me result very faster way. Hope I still have the credits. Okay. So I got this result. If you see here, it is saying what is the source, it is saying what is the source table. So source table is actually here what, it's a XML, correct? So when you go there, you have that uh, tag hierarchy. You have account, inside account you have a customer, inside customer you have the customer ID and all these things. Okay, inside that you have address, contact, all these things. So each tag, it is treating as a source table. So it's a good actually way to actually identify the path. So it say this particular will go to the customer account table, this column will go to policy table, this column will go to the transaction table and all. Okay, it follows something that is not there in the transaction table, so it say like okay, not required. So this is something it is doing very accurately. Right now there is no transformation logic. It doesn't find any transformation logics. It is not giving something. It is giving like see here. So for example, policy premium dot amount, and it is saying like policy premiums. It is say like it's a 1200 premium currency is USD. So you have to convert like that. So this is it automatically identified. This entire thing you can download as a Excel also. So let me download as a Excel. Let me save somewhere here. Let me open it. It's actually similar thing. So you can see the mapping sheet came here. So it's a very basic version of the mapping sheet. We can enhance it the way we want. Okay, let me show you my activity monitor right now. So if you see my activity monitor, here my memories and all, if you see, it is not using much. So it's a 16 GB, right now it is using 9 GB or something. If I go to CPU also it's almost idle, if you see here. Now what I will do, I will try to generate the same output from the local LLM. Okay, so if you see here, it is saying like it is generating ETL mapping sheet via local LLM. Now go to the local LLM, and if you see the spike, it is actually going to use the system CPU. It will slowly increase it. See here, you can easily identify when the local LLM is running, it is using almost everything in memory. So if you see the Olama is something like that is running the local LLM in my system. Itself is taking 14 GB of RAM. So right now if you see, it is almost capturing everything. It is uh, killing entire RAM, and still the spike is going up. See again the red mark. CPU, if I show you something, CPU is pretty idle. It's a good thing. I never see like last time it is got a good spike. Other things are normal. Disk operation little bit go up because of the Olama itself. So because it's running by Olama, it is mostly killing your RAM. It's running in, it is using also, you see here it is using now 17 GB of memory. It's more than the system, I think, now using the buffer memory. So yeah, it will take time. So I might pause the video and I will resume once it's done. Okay, so it took a lot of time, but it actually gave the result. And if you see, after we are getting the result, the memory spike now is going little bit down here. Slowly it will almost cover it. Let's see the result. So this model is little different, and if you see here, it is giving you output, similar output but little different way. So it will say like what kind of table and what kind of transaction ID you have to map and all these things here. So similar kind of mapping also it is providing. uh, both are the different models, so they can provide little different result, but end goal will be almost same. So if you see here, what it is saying, like it is saying like what is your source system, what is your source table, and what is your source column, and what will be the transformation logic, what is the target table, and what is the target column. If we see in when we use the API, it give the sorted order based on the target table, but here I think it is sorted based on the source table. So yeah, this is pretty good what I actually tried to show in this video. Hope this will help you for your AI learning. Thank you so much.